Hello and welcome back to Miles Maths. This is the second video on function notation, and this one particular video is going to be on function of a function. So, as with all my videos, I encourage you to make notes as we go along. Function of a function. We're going to start off with some fairly simple examples, and we're going to recap on where we finished up on one of the last video at some point. So let's have a quick look at where we finished on the last video. A typical sort of example might have been that f of x is equal to 3x squared plus 4. So we might be thinking, so what's f of minus 2, for example? Well, f of minus 2 would be, well, 3 times by minus 2 all squared. The minus 2 is squared in here. The 3 isn't squared because the 3 wasn't squared here. It isn't squared here either. And we would end up with 3 times minus 2 squared. Minus 2 squared is 4. So we would get 3 times 4 plus 4, which is 16. And that would be my final answer. And that's just a quick recap of how function notation works. However, what would we get if we wanted f of 2x? Well, as up here we had f of x wherever we have an x. In this example, we put a minus 2. So wherever we have an x, we're going to put a 2x. So I would now have f of 2x would be 3 times by 2x all squared plus 4. 2x squared, well, I might want to do that at the side of the page. 2x times 2x is 4x squared. So I can say that this is 3 times by 4x squared plus 4. 3 times 4x squared is 12x squared plus 4. And that's my final answer. Let's try something else. Let's try f of x plus 1. Now, in this example, all I did was I replaced x by 2x. So, in this example, we're going to replace x by x plus 1. Stop the video now, have a go, and see what answer you come up with. Okay, hopefully you're back. And what we should have is 3 lots of x plus 1 all squared plus 4. Of course, x plus 1 squared is x plus 1 times by x plus 1. And we know that if we expand the brackets on this, we get x squared plus 2x plus 1. So what I've got is 3 lots of x squared plus 2x plus 1. And I mustn't forget my plus 4 that's stuck on the end over there. So we can expand that bracket out. We can say we've got 3x squared plus 6x plus 3 plus my 4 that's on the end, giving me a final answer of 3x squared plus 6x plus 7. Easy. So here's an example, another example for you to do. What if I'd got g of x is equal to 3x minus 1? Can you find g of 4x? Stop the video now and have a go. Excellent, you should be back. So what I should now have is 3 lots of 4x minus 1. Wherever there was an x, I've written a 4x instead. And 3 lots of 4x is 12x, so I should have the answer 12x minus 1. Nice, easy one. Okay. Let's imagine for a second then that we start to look G5 at f of x equals 2x plus 3 and g of x is equal to 5 minus x. Well, I could now start to think about what happens if I find f of g of x. So what happens if I find f of g of x? Well, f of g of x I would write like that. And although we don't write these brackets in, there are kind of brackets in here. So we can think of this as being f of g of x. Well, f of g of x just says I take f of x, 2x plus 3, except wherever there was an x, I put a g of x, and g of x is 5 minus x. So I have 2 lots of 5 minus x plus 3. 2 lots of g of x plus 3, in other words, f of x. I expand my brackets, I get 10 minus 2x plus 3, which gives me 13 minus 2x. That's f of g of x. Now, what's quite an interesting exercise to do is then to say, so what is g of f of x? Well, g of f of x, e.g. 6, g of f of x is not the same as f of g of x. Bearing in mind, they're not written in, but you can think about there being brackets around there like that, if you want to. So I take g of x, which is 5 minus x. I've got 5 minus f of x. So I've substituted f of x into g of x, and I end up with 5 minus 2x minus 3. 2 minus 2x. Let's, before we finish, try something just a little bit more complex. And you can have a go at this one on the way through. So, here's f of x. F of x is equal to x squared. A nice simple function. G of x is equal to 3x minus 5. Shall we begin with the easy one? Let's find g of f of x. Stop the video, have a quick go. Okay, so what you should have written is you should have substituted f of x into g of x. So I should have had 3 something squared minus 5, and the something squared should have been f of x, and f of x is x squared. So 3x squared minus 5, that's all we've got. And funnily enough, that no expanding or anything to do there, that just comes out as our final answer. Now let's look at f of g of x. F of g of x is a little more complicated. We're substituting g of x, 3x minus 5, into f of x. Stop the video for a second and have a go. Okay, you should be back. So, I'm substituting g of x in, and I'm writing g of x wherever there was an x. So I've got 3x minus 5 all squared. And I can expand that out and say that that's 9x minus 50 minus 30. Sorry, 9x squared minus 30x plus 25. Final answer. And that is function of a function. F of g of x, g of f of x. Please note that f of g of x does not equal g of f of x. Order does matter here. We're not multiplying here. This is function of a function. It's important to realise there is no multiplication sign in there. And that concludes the video on function of a function. Thank you very much. I hope you'll come back to Miles Maths very soon.